So the problems that we're going to look at right now are really not very much different from what you've already been doing. You've been doing mass problems, where in the problem they give you some amount of mass of one thing in the chemical equation, and then you figure out how much mass of another thing in the chemical equation. So what we're going to do today is just add one more little thing, and that is that sometimes in our chemical equations we have gases, and those are more typically measured, instead of being measured in mass with grams, those are more typically measured as volume. And you remember back from the last unit that we did that at standard temperature and pressure we know the molar volume. So for now we're just going to assume that all of our chemical reactions happen at standard temperature and pressure, and we have 0 degrees in all our laboratories, and we have 1 atmosphere of pressure, which is probably more realistic than the 0 degrees. But just for the purposes of making things simple, we will work with standard temperature and pressure. So let's say that we've got this reaction going on here. And there's a couple different kinds of problems. One is called a mass volume problem, where maybe you're given mass of one thing and asked to find volume of something else, or vice versa, you're given volume of one thing and asked to find mass of something else. But in either case, whatever is being measured in liters will need to use the molar volume, where you would be using molar mass if you had grams. So it's really not a very much different kind of problem than what you've looked at before. Now there's also volume problems, which are amazingly wonderful because they allow us to skip a step. Actually, they allow us to skip 2 steps, and we only have to do a mole ratio, and I will show you why in just a minute. But let's start with a mass volume problem. So what if they told us that we were given, so this will be our given, 2.5 grams of nitrogen, and then they want to find out how many liters of this would you produce at standard temperature and pressure, because they have a very cold lab going on. So anyway, 2.5 grams of nitrogen. We're going to set this up just like we did before. Remember that the first step is always to convert to moles. Now if we're given grams, we convert to moles by dividing by the molar mass. If we were given volume, we would convert to moles by dividing by the molar volume. But this is mass, so 28 grams per mole for nitrogen. Now we need to do our mole ratio. We'll get 2 of these for every one of those. So 2 NH3 are produced for every 1 nitrogen molecule that's used. So up to this point, I would have moles of NH3. The problem, however, has asked me if I would please present that as liters of NH3 at standard temperature and pressure. So I'm going to multiply times 22.4 liters per mole, because that's the molar volume at standard temperature and pressure. So this step, just to review, gives me moles of nitrogen. This step gets me to moles of ammonia, and this step gets me to liters of ammonia, assuming we're at standard temperature and pressure. So let's do the math. 2.5 over 28 times 2 times 22.4. Wow, that came out to 4 exactly. Never could have planned that. So let's see, for significant figures, 2, I guess. So we'll call that 4.0 liters of NH3. Box that off, and there's our answer. So that's an example of a mass volume problem. And again, this is the kind of thing where I gave you a reactant and asked you to figure out a product, but you can do that backwards. So maybe we should do one example with that and say, what would happen if I had, in fact, we'll do it backwards 2 ways. Let's say that I'm going to tell you that we're starting with 6.00 liters of ammonia at standard temperature and pressure, and now I'm going to ask you to find, let's find hydrogen, but I want you to find how many grams of hydrogen, just so that we can know that everything works the other way. So the problem will ask me how many grams of hydrogen can you or would you need in order to make 6 liters of ammonia at standard temperature and pressure. So let's start that out, and our first step is to take our 6 liters and convert it to moles. All right, so this is going to look familiar. If we start with the volume, we're going to divide by the molar volume. If we started with mass, we would divide by molar mass. So it's still a division, it's just using a different number. Now, I want to get to hydrogen, so I'm going to say there's 3 hydrogen molecules for every 2 ammonia molecules involved in this reaction. So there's my conversion to, instead of moles of this, I want moles of that. And remember, the problem asked me to present my answer in grams. So I look at H2 and I say that that's going to be 2.0 grams per mole. Again, just as a reminder, I ignored that 3. I don't need the 3 for the molar mass. We've already used the 3 in the problem. Don't use it again. All right, so let's see. Those two are actually going to cancel out. So if I can take 6 times 3 is 18 and divide it by 22.4, that should give me an answer. And well, looks like I used only 2 significant figures for my molar mass, so I'm stuck with that. 0.80, and that is grams of hydrogen. And we'll box that off and we'll call that our final answer. Now I want to show you a very cool thing that makes life so easy with these volume problems. Make up a new problem here using the same reaction, because they are all gases, and so we can do volume problems with this. So let's say that you are given 2.5 liters of nitrogen and you are asked to find out how much hydrogen would you need to react with that. So you know how many liters at standard temperature and pressure. How many liters of this should I combine in order to make some of that and not have any leftovers? Now watch what happens here. First I'm going to go through this with all the steps that we would normally use, and then I'm going to show you why we can skip some steps. You're going to love this. So 2.5 liters of nitrogen divided by 22.4 liters per mole. So that's how we get to moles. We need a mole ratio. There's 3 hydrogen molecules for every 1 nitrogen molecule. Now we need to go back to liters, which means our last step would be to multiply times the molar volume, which is the same for all gases. And that's why we get to skip some steps here, because the molar volume is the same for all the gases. If we're using molar masses, it's not the same. So we always have different numbers and we can't just start canceling things. But with this, we can cancel things, because 22.4 and 22.4 are going to cancel. So all we really need there is the mole ratio. So this is just like going back and doing the kinds of problems that you did at the beginning of this unit, where all you were doing was converting from moles to moles. So we take our 2.5 and multiply that by 3. Let's see, if I multiply it by 2, I get 5. So what would that be? 7.5 liters of H2. And so that's my answer. So that actually makes things really easy if you can just go from volume to volume and you're always in the same conditions of temperature and pressure.